Good afternoon, YouTube. So this recording is the second recording of my testing with OpenShift 4.11 using OVN-Kubernetes, F5 Big IP, and Container Ingress Services, or CIS. So yesterday I recorded a similar type architecture. However, with today's recording, I am testing with a cluster of big IPs, or what is known as high availability or big IP HA. So as you can see from the diagram, there is F5 big IP 60 and F5 big IP 61 with a floating address of .62, which is the floating address that that is there for your default gateway, for example. It's really there for high availability. And so if you've configured big IP with high availability, you are aware that you create a float for your clients to connect to, or for a device to connect to, because that's what really shares the, if you want to call it, connection state for the device that is active. So in this cluster, you can see that there's two big IPs. Let's take a look right here. We can see there is big IP 1 and there is big IP 2. So there's some type of change right there. So why don't we go ahead and just sync these up. So we'll go on to the master big IP. And what I'm going to do is I'm just going to sync the configuration so that before we start, we can be in a synchronized state. Now, what's really important here about this environment is that I'd absolutely recommend a manual sync, because what you see here is, in this current instance, sure, it's one OpenShift cluster, and within the one OpenShift cluster, we have two CIS instances. And the reason for that is because CIS is not master aware, or CIS is not HA aware. So what's going to happen here is that CIS subscribes to the Kubernetes API for that specific namespace. In this instance, it's namespace cafe. So when you create the route, what happens is both CISs receive that route and plumb big IP, but each CIS instance is communicating with one big IP. So that means at all time, the configuration will be on big IP. You don't need to sync it. However, if you don't sync it, it's going to basically show that the configuration is out of sync, or it will show that there's an update. That's exactly what it will show. It will show that there's an update. And I'll show you that in this example. Can you use autosync? Yeah, maybe. Since we're not using any FDBs here, meaning no VXLAN, it's just routing, possibly. It's basically exactly the same because you're using AS3. But you have to understand that each big IP is going to get the configuration independently. Now, you could send the traffic just to one and sync it over, but what happens if that big IP that you send in the CIS control plane stuff to goes down? Then you don't have any update. So this is why it's better to run two instances. Make sure that the CIS instances have a unique name. You'll see it in the configuration. So let's get back to this document. So this document describes how to use OVN Kubernetes with F5 Big IP HA using routes, and really that is to ingress traffic without using an overlay. So what does that mean? Well, that means you can use OVN Kubernetes with big IP routes. So routes are like static routes, right? So using big IP routing or routes removes the complexity, or removes the requirement from having to configure VXLAN or any tunnel, or potentially having to use Calico. So in the past, this solution required a Calico environment, or it required VXLAN, but the VXLAN configuration, to be honest with you, it was actually quite tricky for high availability because you had to create quite a few floats. So in this instance here, it's way more simpler than having to worry about that. Let's go take a look at the self IPs. So you can see on the one big IP here, we have an internal, external, and in this case, I only have the external float, right? So back up my diagram right here, 62. It's just a floating self IP, and you can see what's unique about it is that the traffic group of 1 is associated to that float, and that address is shared on the second device. You can see right there, it is shared across the second device. So that's the device that is going to be floating between the two devices. So you will always just talk to almost kind of looks like it's one device, but that's kind of how it looks like. And so that's why you see from the diagram, that's why you see here is your floating self IP, here's also your floating self IP. And then in the namespace, you configure this routing external gateway with the floating address. And so this is how traffic can get back to the big IP. It'll go back to the floating, which will then go back to the active big IP. That's pretty much it. So within this cluster, it's a 3-node cluster, right? That's 3 masters and 3 worker nodes. And we have 3 applications, tea, coffee, and mocha on a cafe namespace. And so what we're going to do first is just go ahead and change the network type to OVN-Kubernetes because it's 4.11. I believe 4.12 OVN-Kubernetes is going to be default, but again, check with the OpenShift PM. One thing that we need to do first is verify that gateway mode is shared. Now this is default, right? But I'm just going to go ahead. This is the documentation that I got from Red Hat. So I want to just share exactly what Red Hat sent me. And you can see right here, I ran this command basically from the logs, and I can see that gateway mode is shared. So it's basically shared gateway mode is the ultimate mode that we're running in. And again, you can ask your Red Hat OpenShift consultant for a little bit more information about shared gateway modes. But basically you can see here are my 3 worker nodes. And so what I need to do is I need to pull the pod network, right? That's the network where the pods are going to run. And I need that for the static routes. So you can actually use this command. It's quite simple. Describe the node. This is the name of the node. And grep for the node subnet and the primary IP address. Primary IP address is the IP address of the pod. Of the node itself. It's the node IP. And here is your subnet of the pod. So you can see right here, I'm at 129.2, and this is my host address. And so when you get all of the host addresses for all of the pods, then you create static routes. So in my example here, I got 3 worker nodes. So what you would do is you would create static routes for all of your worker nodes. Now you can create quite a few static routes on big IP, but you do need a unique static route for each node because each node is going to have a unique host network. So you can see 10.129, 10.131, 10.128. So kind of unique. And then what you need to do is create the three static routes and then just manually sync. So once you've created the 3 routes, just sync up from one side to the other. It will push the configuration over. So you only need to create it on one device. You can see here that here is my pod host subnet, 128, 129, and 131. And the default gateway is basically the node IP. OpenShift will take care of all the routing if you have shared gateway mode is true, which is default. You don't have to do anything. So the next thing that you need to do is, like I said, configure the egress. So this is a namespace. So this is going to be within your namespace for your pods. So if nginx-ingress controller is your pods and big IP sending traffic to nginx-ingress, then it's going to be nginx-ingress. It's going to be the name of the namespace. In my case, my pods are cafe. I'm doing big IP to pod, cluster IP. It's all cluster IP. Big IP will connect direct to the pod. No reason to deploy node port. To be honest with you, now that we have this network, this environment, node port's not required. In fact, node port's actually more work than potentially just creating static routes, right? And node port, you got proxy to proxy. I'll show you how cool this is when I set up some traffic. So once you've done that, you're finished. I mean, that's it. That's all you got to do. And this is for HA. By the way, if you're doing standalone, the only difference is that that's going to be the self IP. As I said, that's the only difference. So between HA and standalone, the only difference is the routing gateway. Other than that, you've got 2 CIS instances. So as you can see here, we've got big IP 01, big IP 02. So there's the .60 and there is the 61. Now, some people say to me, can you point big IP to the floating? No, yeah, potentially. But to be honest with you, this is the support model. This is the model I'm going to document. And this is the model that I'm going to ask the support engineers to support, because this configuration is fully supported, right? Which means you can basically open a service request or a GitHub against it. So kind of follow with what we've done, because that's what we're going to test. So once you create your two big IPs, give it username and password, your cluster role binding, make sure you pull, please, get the latest cluster role bindings, like because Kubernetes is changing, right? OpenShift changes. We're on 124, 125, 126. There might be some cluster role binding changes. I can guarantee you in 124, there are changes because they implemented security at the pod, right? So there's going to be some cluster role changes. So please pull the latest one. Deploy 2 CIS instances. So you can actually go and take a look. Let's go look at OpenShift. So we'll go to the workloads, we'll go to the pods, we'll change it to kube system. There's our 2 CISs. And if I actually probably look at the CIS, if I actually look at the logs, it's probably pretty quiet. There's really not much going on there, right? There's a little bit of node puller, and this is just debug. But if you were in info, you wouldn't see anything. Right? So it's super, super, super quiet. And so, yeah, you can see there's nothing really going on. And so if we go look at big IP, there is no configuration. So back to OpenShift, go down to network. Let's go take a look at network. There are no routes. And they are some config maps. This is actually new. I believe this is actually part of OpenShift 4.11. Now this is interesting. Let's take a look at this YAML file. Okay, so we'll go back to the diagram. We'll talk a little bit about this in a second here. But I know that this is mine because I can see my cafe there. So now that you've deployed CIS, the next step is to deploy something called a global config map. Now you might ask me, Mark, what is that? Well, welcome to next gen routes. We've completely refactored, architected routes, and this is going to scale better. And I believe that this is going to work really well for this multi-tenant user preferably, because what really is happening here is that your global configuration, right, your advanced configuration is going to go into the config map. And yeah, it's a config map, but it's pretty simple, right? So for example, here, this is cafe namespace, okay? But I can create as many namespaces as I want, and I can assign a public IP to that namespace, So how cool is that? So that means that CIS is going to allow you to create multiple routes within a namespace for a specific public IP. But it will also allow you to create multiple public IPs. So for example, 65, 66, 67, 68, etc., etc., etc. Watch out, 2.11 is going to support a policy CRD in this config map. It's a reference, which is going to allow you to configure all of your policies. Why policy CRD? Because we've already written it, right? And so it's well tested. It works really well. Policy CRD covers stuff like iRules, WAF policy, bot, DOS, login, profiles, pretty much everything that you need. So just reference it here in your extended route spec. Certificates, just reference them here. And then you let your users create the routes. And CIS will plumb everything together. You wouldn't have to worry about it. So that's the whole purpose of the global config map. And so that's what you can see, what I've done here. Now, in this example here, I just have cafe. But what I can do is I can add cafe new with a new unique virtual server and a virtual server name. So that cafe name, as you see right here, which on my big IP is nothing because I don't have any routes. So at this point, let's go and create some routes. So I got 3 routes here. So what I'm going to do is, these are secure routes. So I'm going to go create some routes. So OC create -f, and these are secure routes. And so there I've created 3 routes. So coffee, mocha, and tea. And if I go to, and by the way, there's the name of the route. So that should show up on Big AP. There we go. You see that? And that's 443. That's the name of the route. Now, I only see one virtual IP because it's all based on the path. So if I go into resources and see, I can see the routes here. There is coffee, mocha, and tea. And if I go into OpenShift, go down to routes, almost tricked me there for a second. I was like, I don't want to re-record this demo, but I can see that it's changed that. That is pretty cool. There we go. So there's my routes. There is my route status. You can edit the route. You can copy it to clipboard, cafe, mocha, tea. Now, routes are cool. Next-gen routes are even cooler. Why? Because there's some cool stuff coming. EDNS is coming to external routes. Policy CRD coming to external routes. And maybe next year we'll do next-gen ingress. I don't know. But let's not get ahead of ourselves. But let's test this out. So we've got our routes, our OpenShift routes configured, and our big IP routes, right? Both routes. This is all routing. Should I sync it? It's up to you. I can go and sync it just to make it look nice. So go to the active. Oh, here, go sync it. You can sync if you want. It's out of sync, I know. Nothing I can do about that at this time. But this is actually pretty cool. Okay, so both in sync right now. There's standby, there's your active. Let's go play with some traffic. And let's fail over. And let's see if this whole thing works. So here we go. Let's click on coffee. Let's click on mocha. And let's click on tea. Okay, you can see it's incrementing. So the request IDs are going up. So I'm not playing games here. Request ID is going up. So what are we doing? We're load balancing traffic to coffee, mocha, and tea. And big IP has a virtual in OpenShift. Now, if I go to local traffic or traffic map, I don't have a health monitor, so that's basically kind of what you see. But what I want to do is I just want to close this out because I want to kind of watch this active status. Okay, so what I'm going to do is I'm going to fail this over. So let's go to the standby, and let's see. First of all, I have to change them both to common. So let's change that to common. Then let's go to here and let's force this to standby. And that's what I did. I forced it to standby. You can see the clicking here. So you can see the request IDs are incrementing. You can see I'm just running auto refresh. So these are incrementing. And so this is now the standby, and this is now the master. And so probably just what happened is they just reconnected, right? Because it's all web traffic. It's very simple, right? As you can see there. So just a reconnection, probably reestablished. How about we fail back? Click on here, force to standby. So now we've gone back to the active pair. You can see right there, active. Look, 0 issues with that. So that is pretty cool. So what that demonstrates is a fail from master to standby, and then back to the standby, and fail that over from standby back to the active pair, right? So active standby. So that's kind of the failure between the two, and you're able to see the transaction works. No blank pages, nothing broken like that. So we created our routes. We looked at our routes a little bit. This is next gen routes, very simple. Kind of like this gives you an example what they look like here. So let's go take a recap. So what I just showed you was big IP high availability configured with OpenShift 4.11 using OVN-Kubernetes, and what we're doing to make sure that our traffic is working correctly is using static routes of the pod networks pointed to the nodes, and that's pretty much it. Make sure that you have your floating set up correctly. You can kind of see your little gateway route, little OpenShift gateway router on each node. And so that's how the data plane traffic is getting to the pod and back from the pod again. I want to show you one thing quickly. So you can see here that it's cluster IP, right? Because this is the IP address of the floating right there. And here's the IP address of the server address. There's no node port here. And so this is all set up based on the service. So if we go, actually we can go in here and actually look at that deployment. We probably got to go down to the networking because it's probably not going to show us. So let's go down to the service. Let's go take a look at the coffee service. And from this coffee service, I might have to edit it. But yeah, oh, there we go. It's cluster IP. So that is the actual cluster IP location. And that's what CIS is configured for. So CIS is still using cluster IP. We're not using node port. But what is kind of unique here, there we go, cluster IP. What is kind of unique is there's no OpenShift information here for the tunnels. It's all gone. So the device is actually super quiet, which I really appreciate. It's not a lot. There's just not a lot going on. So if you go back and look at the logs, you can actually see here, yeah, there's really not much going on other than just some debugging. But yeah, it's actually pretty quiet, which is actually kind of nice. So that is the demo that I have. I have the entire repo here. So just pull my repo if you want to test this out. We're going to document this as part of the CIS 2.11, which is going to ship around the 30th of November. But if you want to get early release code, this is supported today. I'm running 2.10.1. So you can do this with CIS 2.10.1. There's no development needed here. It's just verification. So, but I'm going to update the docs with that release. but you're welcome to use this. But if you want to get some advanced code with some of the new stuff that's coming out on 2.11, just reach out to me. If you like this video, give a thumbs up. If you're not subscribed, make sure you subscribe, because I think that there's going to be another cool video coming this week, and potentially some interesting stuff next week. I'm just not going to get ahead of myself. But my goal is to keep this updated. I know the last couple of months I've been really busy with AS3 and next generation platform, etc. So, but I do promise that I'm trying to get a video out every week, even if it's just pretty short. So thank you so much, and really appreciate the time.